All right, once again, a warm welcome to today's webinar on shaping cities using urban digital twin, organized by SG Tech and Dell Technologies. Thank you for taking time out to join us. My name is Christine from SG Tech, and I'll be your MC for the day. Some quick housekeeping before we commence the program proper. This session will be recorded for archival and marketing purposes. SGTech may use some or all of the images or videos in its print applications, digital platforms, and marketing channels. Recording will be made available post-webinar on SGTech website. Do send in any questions via the Q&A feature at the bottom of the browser, and they will be addressed during the panel discussion segment later. Today, we have an amazing lineup of speakers. We are honored to have Mr. Anthony Ong, the chairman of SG Tech Smart Nation chapter, to do the opening remarks and moderating of panel discussion segment. Mr. Martin Yates, who is the Global Chief Technology Officer for Digital Cities of Dell Technologies. Martin is an experienced leader and enterprise architect in many domains such as smart city, national defense, energy, manufacturing, and financial security. He and his digital city field team perform research, design, and deployment of technologies meeting the goals of a human-centric, secure, and sustainable, environmentally focused digital cities society. Martin is a Singapore grassroots leader supporting community and national programs. He is also a Singapore citizen residing on the East Coast. Lastly, we have Ms. Bai Lu, who is a senior technologist of Dell Technologies. Bai Lu has strong digital transformation experiences and adept at leveraging cutting-edge technologies like digital twin, AI ops, analytics solution to achieve better customer experience, cost optimization, and process improvement. She is the field solution consultant of Dell Global Digital Cities. So without further ado, I'd like to invite Mr. Anthony Ong, the chairman of Smart Nation chapter, to address the audience. Anthony, over to you, please.
Thank you, Christine. A very good morning, everyone. Welcome to Shaping Cities Using Urban Digital Twin. My name is Anthony Ong, chairman of SG Tech Smart Nation chapter. My day job is the group CEO of Adera Global, a Singapore company offering computer vision and AI solutions. Today, I'm actually honored to be your moderator, joined by two experts from Dell Technologies on digital twins, Mr. Martin Yates and Ms. Bai Lu, and they will bring us on a wonderful world of digital twins later. Before we jump into the world of digital twins, please allow me to share briefly what SG Tech and Smart Nation chapter is about. So we are one of the chapters in Smart Nation chapter, and today the fashion and trendy words is moving towards sustainability. Yeah. So SG Tech is a premier trade association for the tech industry with about more than 700 members, range from innovative startups and also medium-sized enterprise to top multinational corporations that leverage technology as a core driver of their business. So what is Smart Nation chapter about? So the purpose of the Smart Nation chapter is we aim to promote thought leadership in technology and solutions, promote collaboration between members, and advocate internationalization. So a quick introduction of my team in the Exco members of Smart Nation chapter. So what are we going to do this year? So promoting thought leadership, We are going to be more active in industry participation in Singapore Smart Nation initiatives. We get private sector onto the smart solution bandwagon, and we want to help SME grow towards regional and internationalization. So Prime Minister has always said that the race towards becoming a sustainable smart nation. So it is all about building a technology that helps people and make a difference to our lives and across the whole society. So digitalization of the built environment, and this is where leads to today's topic of building digital twins. So without further ado, let me introduce Martin to take over. Over to you, Martin. Thank you.
Thank you so much. It's great to see you all today. I wish I could see you. We're not on camera, but I can see there are many people out there. So let me just fire up the PowerPoint and let's get started. So thanks very much, Anthony. In the next 20 minutes on my segment, and in the next 20 minutes after Bailu, we're going to take you on a whirlwind tour of the digital twin and how they're being used in cities. So let's start with the first lead to the insight. Now, I started like really full-time, properly deep research into digital twin about 2 years ago. And I was thinking to myself, okay, this is a new top trend around the world for cities and nations, so I probably need to spend 1 or 2 weeks on researching this topic and being able to deliver outcomes to that. How mistaken was I, right? It really is such a big topic. It's a bit like cloud computing and perhaps even more. And so what I wanted to say to you today is that you are all on a journey, wherever you are, whether you're from IT, whether you're from business. There's so much to learn. There are so many books to choose from on digital twin. It's almost kind of like difficult to know where to start. So what we want to do today really is just give you that insight, and we're just going to literally take a book off the shelf and flip through a few pages as some insight to really sort of get you started. And it's our honest hope that you continue that journey and you see the value, and then you can deep dive into the specific areas of digital twins that actually sort of interest you. So here we go. Now, I mentioned like taking a book off the shelf, and I remember thinking, yeah, this will be relatively straightforward. I'm going to get this fired up. And then I realized when if you want to Google digital twin, how many people are involved? And this is just realistically from a more of a city and a national perspective. And, so many organizations, so many ISVs, so many system integrators. It's really difficult to get your head around this, and so I kind of reset my kind of calibration as well. Like, okay, this is going to take a few more weeks to learn than what I'd hoped, because seriously, you have to be able to take in all these different vendors, all these different approaches, and make sense of it for your situation, for your life. And so clearly this will be something for the ongoing discussions that we can have outside. But I think this is just a few examples. Some of the logos that you see up there, some classic there's some classic Singapore companies down there at the bottoms there, but it really is it's a global consortium of companies all across the world, seeing the value of digital twin and surfacing that value to their governments and to their customers. So from an architecting of a city or a nation, there's a certain set of underpinning technologies that we've always been going through. We've seen the need for cloud computing has been increasing, both on-premise cloud computing and off-premise and a hybrid multi-cloud. So that continues to be used, and we see that there's this massive spike in number of IoT devices. Look to any buildings now, look to any road. The roads are littered with all sorts of devices that are lighting up and sparking up and streaming out data. And of course, what we've also seen is that there's so much data that we can't send everything back to the data center. That's absolutely crazy. So we need to be able to start doing in real time some analytics at the edge. So you're seeing more and more of this. Yes, lots of IoT from hundreds to thousands, 100,000 to millions. And now let's get the edge analytics running to make sense of that data as we see it at the at the location before everything gets sent back to the data center or into the different data lakes. And of course, the increasing use of AL, ML, DL, HPC, high performance computing that needs to be applied to that data that you're seeing is continuing to be faster adopted. And so those people that are really in their game are going to be across those four there. Now, digital twin has been more of a late entry to many people's agenda, and so we're now seeing that at least 50 to 60% of cities that want to think about going digital are now including the digital twin as part of their agenda. And so, of course, we've had to respond to that. We've had to put together solutions and concepts and ways forward to help people on that journey. And I'm sure within the next 6 to 12 months, we're probably going to find like perhaps 70 to 80% of all people have some form of digital twin in their agenda. Now, if you are responding to that, if you are building that for your organization, you really need to be on top of that. So digital twin is the topic that we're really focused on today, and specifically within the zone of digital cities, smart nations, etc. And quantum computing is a little bit further out there. I won't talk to that now, but a great topic for later. Now, underlying that, having that data management, that protection, that blockchain, that cybersecurity all needs to be in place, because without that, you don't have a twin that can operate. And I'll explain a little bit more about that later as I go into the next slides. So when we look at the digital cities vision, the smart cities vision, and where does that apply to digital twin? It applies pretty much everywhere, like within the safe city, if you're doing disaster resilience, whether you're doing urban planning, whether you're doing mobility or traffics, EV chargings, things like this, whether you're looking at energy, sustainability, citizen health, citizen wellness, hospitals, healthcare facilities. Also, it touches onto education, government data centers, and right into the smart industry as well. And in that edge of smart industry, digital twin, you'll see used by many companies, great engineering companies. So digital twin architecture can be applied to pretty much anything that moves in the digital world. And so that's something to be aware of. And from whatever industry you're from today, I certainly hope you're going to have the ability to take advantage of that if you're not already. Now, the great thing about having so many people on this call is I don't know all of you, and I don't know where your starting point is. You may be already a guru, you may be, I've just heard about this digital twin, what's it all about. So forgive me if I just start a little bit more at the ground levels here. Basically, a digital twin is taking something that lives as an analog asset and converting that, or an analog process, and converting that into a digital asset. An asset that can be fully manipulated so that you can build stuff, and I'll come back to that later. You can build stuff in virtual world before you ever create it, and you can manipulate it and understand it and make sure that what you're designing or your service models that you're creating are going to be just right for your environment. And so that then turns the whole focus to building digital replicas of cities, building digital replicas of buildings, building replicas of tunnels, and everything that's operationalized around that. And we'll see a few more examples of that as we go forward. So at a very high level, what we're really doing is we're taking all this information, whether this is IoT information or building type information, we're extracting that and turning that data into information, and that information into the knowledge, and turning that then into a value. And that's now where we build that digital twin model. And just on the right side, I'm not going to go through all those. You can see some of the areas that this really makes sense. As I mentioned earlier, like smart building, predictive maintenance, intelligent logistics, smart robots, quality compliance, production, asset management. The list goes on and on. And so I'm absolutely sure whoever you are and wherever you're coming from, something there will be for you, and to be able to take that digital twin into your process, into your life, taking that forward inside your organization. So, like we look after digital transformation in Dell Technologies for many different topics. And, people often say, so look, I hear what you're saying, digital twin, it's important, but where should it sit? And what we really see is that many organizations that are already implementing IoT actually have the plan to use a digital twin, like they're actually using it right now, or they're planning to. So that's a good indication that the world is starting to figure out this might be something that's useful for me. And why do it? Why spend the money in the first place? It always has to be about a return on investment. So, and for us, and this is our experience of what we've seen, is that it gives you the opportunity to build things, to stand out, to differentiate your products. It allows you to build new services much faster with greater confidence because you already checked it out and you did all the what if scenarios. And so you can bring these things to market with much greater confidence than ever before. And it allows you to create, once you've built your digital models, you can start sharing those with people and start selling them or do collaborative work with other people to improve your business revenue streams. So again, great thing. And one of the great things we love is this optimized operations and troubleshooting. So a whole building can have a digital twin and we can fix our building faster. We can be much more predictive. Again, by measuring that against what is in an ideal world of a digital twin. So this really, the tools that we're essentially looking to is this, to be able to build and visualize, simulate that business model that you have, whether that's a physical or whether that's a process model. That's the areas that you're really going to be looking into. And, take your choices in which one's most important to you. Building faster service models, operations, and I'll get into that in the next slide. So when we first started Digital Twin and we did our research, we realized there are so many ways of slicing the cake of Digital Twin. And I think if you Google right now, you'll probably find at least 10 different models from different organizations, from different businesses in the past that have tried to break down what is a digital twin. And they're all correct, but the syntax varies. And so what I cooked up on the screen for you here is this is about as simple as that I could get the digital twin, right? In terms of, because you will find ones with 5 steps, you will find ones with 7 steps, you will find ones with 12 steps. So I said, no, it's too complicated for just a quick introduction today. So I've boiled it down into 3. So what you need to know really, number 1 is a simulation twin. You're building a product or a service or a process, and it's not created, you're just basically creating a simulation twin. You've built the building in 3D, you've taken the model, you've imported it, you've added your sensors, you've added your science and data to it, and now you can manipulate and try things out in that simulation. You can build jet fighters or cars or buildings or tunnels, all within simulation without you actually physically having to go and build that. And that's a very, very powerful use case, one of the powerful use cases for digital twin today. Now, number 2 is what I call the status twin. This is really I have my building and it's got all of its centers. I've got my city and it's got all of its centers. And I'm reading and taking that input. And so I'm now taking all that real-time information, all that process information into my model, and I can see what's happening, right? And I can compare that against twin, so I can produce great reports from that. And I can try things out in combination with the digital twin simulation. Now, thirdly, the operational twin is going to the next level. The operational is more okay, I can see that my building optimum twin says that this is how my building should operate. And in the status twin, I can see that working fine. But in an operational twin, I'm actually now saying, I'm taking that data and also I'm modifying thermostats, I'm modifying air conditioning, I'm triggering events. I'm doing all of this unattended, and so very much that operational twin allows you to take your hands off and things are taken care of with the operational twin. So that's more of a two-way communication. Something's out of specification, now I'm going to send a signal for that to be put back in. So those are the easiest ways that I could boil down a digital twin. Now, in your research going forward, you're going to find lots more examples. I won't go into that today. The other thing is what we call the digital threading. That's taking snapshots of those processes and products from when you visualize the product from day 1 all the way to when you end of life the product, the building, or the service. And so that's an important part of the journey as well that we're seeing that goes with those digital twin. Now, all of that is critical to pull from multiple data sources, IoT, AI, processes, analytics models, transition models, master data models. All this data is required to be able to build an effective digital twin. Now, depending on your circumstances, depends on what kind of models you'll use. You may use some standardization models, maybe for fluid dynamics, geospatial, oil and gas, or aerospace. All those models are starting to be standardized, but there is no true global standard right now. This is the space that everyone's busy working on. So when we look at what we can do in a city, these are all the snap-in modules we can have for a digital twin: smart waste, smart streets, smart surveillance, smart emergency disaster, smart traffic. So all these can snap in into that core system that allow you to be able to provide that simulation model, that allows you to provide that shadow modeling, and allow you to provide that operational modeling. And there are many, many more options that you can snap into that. Now, is it easy? No, that you have to do a lot of research, you have to do your fact finding. But this is the model that we're seeing that allows people to deliver effective outcomes for their cities and for their nations. So a little bit more technical now. It's not my intention for the minutes, just a few minutes left to go into this. But essentially, what you can really see here is essentially all the IoT devices themselves, or the data themselves, being able to broadcast out to the digital twin enabled services where the machine learnings are applied, where data processing is being applied, and checking that against the twin model itself in your private or public or multi-cloud model as well. And you'll have all those training models in there to say, is my twin performing optimally well? Is it doing all the right things? What actions do I need to be taking? And so that's the general purpose architecture. Of course, I won't go into that today because there's already a lot. I can spend 1 hour just on this piece alone. It's beautiful. But essentially, that's the breakdown of the architectures. You see it now. Those architectures will vary depending on who. Remember, right at the beginning, I showed all the different pictures. So the architecture, it will vary on the block level, but the principles themselves will remain the same. So you'll see lots and lots of pictures that look like this from different people's points of view. But essentially, the model overall will look something like this. So this is a great digital twin. This is a city being built in a digital twin model before it's actually been created. This is the Toyota Woven City. It's all being built as a digital twin model, fully optimized, checking the mobility, checking the electric cars, checking the livability of the buildings, carbon neutral, etc. That whole process life cycle is being validated in a digital twin model for absolutely everything, and it's kind of amazing. So do take a look to that on the website. Have a Google on that. I think you'll be very impressed. And we've been happy to be part of this program for quite some time now. So just quickly. Bringing all the pieces together in a city: emergency services, water, electricity, all those data points that I said, all need to be brought together. The messaging, the data streams, the videos, all need to be put into a data lake or into a data warehouse. And then your digital twin can be snapped onto that and start using that data and start manipulating and using and delivering outcomes and results that are needed for your city or even for your business. And you can apply that to data centers. So if you've got a data center and you want to become, better and better on power efficiency, you can build a digital twin data center. That's completely possible as well. And this is really good for those people that are looking to optimize their costs in data centers. Build a digital twin model, try things out, simulate things, do predictive maintenance on it. This will help you with your power efficiency. And so a lot of organizations are doing this in the world today. So closing points to me, really, there are so many areas. You might want to consider doing one thing. It's still emerging. It's not fully mature, such as like cloud computing is much more mature, but digital twin is still maturing, at least in the city and national marketplace. So do check that solution roadmap carefully with whoever you're working with. Make sure that it's going to stay with you. There are many offers in that market, as we showed, and so making those right choices can be a concern. I can definitely share that with you. Do pick a priority business need and try a small pilot. You don't have to boil the ocean. Try something, get used to it, and start to build your skills in that. So with that, thank you very much. I'm martin.yates@dell.com. You can reach us and we'll have a Q&A at the end. But up next, I'd like to introduce Bai Lu, who will take us through some of the more detailed urban examples, so much more focused. So with that, thank you very much. I hope that was as quick as I can make it. And over to you, Bai Lu. I will stop sharing my screen. Thank you so much.
Thank you, Martin. Okay, thank you, Martin, for the introduction for the digital twin. And good morning, everyone. Thank you for your time this morning to attend the webinar. And Martin has given you a very broad introduction for digital twin and what it is, and the general architecture and many use cases in the digital twin space in general. And now I'm going to talk about what is a digital twin from an urban perspective. But as Martin mentioned, this is really a huge topic, and we are trying to cover as much as possible in a broader range for the next 20 minutes to half an hour. So if you have any questions for a specific area that you do not see here, feel free to post your questions in the Q&A box below this webinar. And a summary of what Martin mentioned before, there are many different digital twin products in the market. Each of them is addressing different domains from component levels, such as machines and cars, all the way to international levels, such as the recent Destination Earth initiatives by European Union. From smart cities perspective, our focus areas are, of course, digital twin for cities, or we call it urban digital twin, which covers from building level to city level. And of course, it can also be extended into project levels such as building and construction industry, as well as national level use cases. For example, in a construction site with a digital twin platform, we can compare side by side the actual progress versus the planned progress. In a building management, a digital twin can help with emergency and evacuation planning, as well as building management. At portfolio or city level, the different specialist area can develop their own digital twins, such as noise pollution or traffic simulation platform. For city level and national level, a digital twin can also help with use cases such as estate planning and natural disaster planning. And we will talk about the different use cases in the slides later. So why there is a need for digital twin platforms specifically for cities? The World Economic Forum predicts that the current 4.2 billion people living in urban area will increase by 2.5 billion by 2050. So this increase in urbanization will create more and more challenges for the cities, and therefore increase the need for a digital twin platform to address these incoming challenges. So let's look at the definition again for urban digital twin. It is a digital replica for a city, a virtual model of its roads, the buildings and public spaces, combined with real-time information feeds from sensors and other data sources. It has 3 layers. The first layer is the physical layer, which is the world that we currently know and experience through our 5 senses. And the second layer is digital information layer. It is built through the sensorization and digital mapping of the physical world. We will eventually create a digital twin of every object in every place. And today, this type of digital information is primarily accessed via screen and dashboard. In the future, it will be retrieved primarily via the spatial interaction layer. So what is a spatial interaction layer? On the right, it is the next generation interfaces, for example, the smart glasses. We will be able to interact with contextual real-time information that has been caught up by intuitive and sensory triggers, such as geolocation, computer vision, and voice, and gesture or biometric commands. In effect, these merge with the digital as well as the physical layer for the users. There are many ways that we can classify the urban digital twin use cases. So for example, according to the functions of a city, such as transportation, energy, and environment. In this introduction webinar, we prefer to classify the use cases according to the city lifecycle management, which we think can give you a broader perspective for urban digital twin as a whole. And the different stages are planning, design, and build, and operation, as well as maintenance. Digital twins are finding success in the wide range of domains relevant to cities, and each of the domain is potentially bringing in different data and also has different challenges to in terms of implementation. So defining your use cases, as what Martin mentioned, can be very crucial to your success. So we are listing down some of the use cases here. For example, in terms of urban city planning and city simulation. For example, in urban planning, zoning, and development stage, both greenfield and older cities are better managing their development by using data to better visualize the impact of new buildings on the areas around them. So by managing the land use, the economic opportunities, as well as the physical impact on the wind and shadow even, they can answer the questions from the public in a much more detailed way. And the type of data that we can use in this kind of example and use case can be land use, it can be building footprints and details, and even shadow or wind patterns to see what will be the impact from the environment to the new estate. And for the city departments, it can be GIS department, can be planning department, it can be zoning boards, or even economic development. From a city operation as well as maintenance perspective, we can have the one on the right, the environmental and climate simulation and monitoring. So for environmental monitoring sensors, we can have sensors that measure the noise, the air pollution, temperature, water levels, and flood risk. They can be all used to look at both the quality of life issues, for example, the life complaints, and also the scenario planning around the climate change and sea level rise, for example. So in cities, this is a factor that can be better planned and developed, and to see how this kind of critical infrastructure is impacted. And the type of data and technologies that we can use in these use cases are IoT sensors and water level prediction, the climate models. And yeah, on the bottom of these slides, we have assets and infrastructure management, which is a very important segment in terms of the operation and maintenance of a city. And asset management, and especially preventive maintenance, is a pressing need for cities that need to make their infrastructure dollars to go further. Modeling when infrastructure needs service or when new infrastructure can have desired outcomes becomes easier with a high quality platform. So the type of data here can be asset tagging and geolocation, IoT sensors as well as this what kind of infrastructure that we are having inside the building. So for the city departments, it can be more specifically referring to the building management, the parks and public works, and even transportation. For public safety and crowd analysis, for some of the cities are using surveillance as well as scenario planning around critical events to understand if something is going wrong and how to deploy resources such as police and how to move people out of the harm way efficiently as well as safely. The type of data that we can use here, it can be optical sensors, the videos, as well as GPS information. Of course, we have other use cases that are not listed here. For example, facility management for building and campus, as well as the energy management for the entire city. For example, how we can reduce the carbon footprint and how we can find strategic places to add solar panels to buildings. So cities are using these kind of technologies to better plan the deployment and opportunities in terms of cost savings. And these are the examples for mobility simulation specifically, which is very important in both city planning and operation stage. We can create a digital twin to simulate all aspects of mobility and traffic. For example, if the population of a city is going to be doubled in the next 10 years or 15 years, and what will be the change in terms of mobility demand and traffic, and how will this change in mobility demand affect air pollution and noise pollution, and what will be the further impact in terms of global warming, and what is the potential for clean and renewable energy, and how can it mitigate the negative impacts for the increasing mobility demand. So we can use this kind of simulation platform to create a digital twin for a city to analyze and to simulate the different outcomes, so we can better assist the city planners to plan in terms of the mobility and transportation. So some other examples in terms of city planning. So if we want to build, for example, redevelop or demolish one of the buildings and replace it with the new one, the city planners can even use this platform to just take out a building and place new building, so that we can see whether it can fit to the surrounding and how it will impact in terms of traffic demands as well as the people flow around this area. We can use the information in the platform, for example, the nearby amenities and what is the transportation route in terms of the planning of this new estate area. Another example, we briefly mentioned it earlier, is we can also apply it in the construction industry. So for example, we can have side-by-side comparison in terms of what is an actual model versus what is the plan model, and we can spot the difference. So this kind of difference is very crucial in terms of construction industry, so we can ensure the safety of the worker as well as how smooth the project is. So who are the end users and who are the users that we are talking to for urban digital twin? As we mentioned before, city planners may have pain points such as the impact of city traffic due to a new development, or the impact of air pollution due to a new factory. And a city operator may have operation challenges such as real-time waste management. When we interact with these different personas, we gather different pain points as well as use cases, so that we can help our customers to customize the solution accordingly. So where do we begin with to build a digital twin? And I mean, we can always start from smaller units of a city, or building blocks of our city, which is the campuses as well as buildings. As we all know that most campuses already have their own siloed or point solutions. For example, they may already have separate systems for surveillance. They may have a systems for waste management or energy management. As we can see from earlier example, a digital twin platform minimally needs all these point solutions to be interconnected to form a digital core, so to make them more intelligent, efficient, as well as responsive. So it is a step-by-step process. First of all, we have our assets. For example, we can have cars, we can have thermometer, we can have camera, smoke detector for fire hazard, even human, we are also an asset. Then we can change these assets into smart assets, means how can these assets be able to send data out? The next stage will involve to build a smart and connected asset, which means we should be able to view all this data remotely from a web portal or a mobile phone. That is the minimum. And the next stage will involve building a connected systems. So which means that these different systems can interconnect to each other to form, for example, automation scenes, such as in an indoor car park. If lights can be automatically switched on and off depending on whether there are people or car movement. Then we have the foundation to build a campus digital twin. So with these different systems interconnected, remotely controllable, we can use data analytics to enhance the campus experience. So eventually, the campus systems will scale and connect with city and state systems to become a system of systems. So now we know that a smart and connected campus is the foundation for creating a digital twin. So that is the first stage. And once we have all the data coming in, we have all the systems interconnected, and we know the relationship between the different assets as well as different systems, and what is the hierarchy of these different assets. then we are ready to build a campus twin platform. Apologize for the disruption. Okay, so the second stage is when we have all this data coming in, then we can build a simulation and visualization platform. We can also use data analytics to have deeper insights for all this data that we gathered. So this will come to the final stage or our desired outcome for this campus digital twin service. So once we have data analytics to have deeper insights for different assets, for different scenarios, and we can do simulations, then we can create campus digital twin service. So for example, we can have integrated customer support and field service. We can also have a better quality in terms of supply chain performance, for example. So in terms of smart and in terms of campus and building digital twin platform, we can have many different scenarios and solutions and services that we can provide for this platform. For example, in terms of security monitoring, access control, as well as emergency management, we can have a single pane of glass for all these different solutions, so that we know so that we can have an overall situational awareness. We know that, oh, this is happening because of the case A is happening because of case B and C. And for all these solutions, we can then have a single pane of glass to have a deeper insights of what is happening inside the building, inside different levels, inside and to analyze what is the behavior of the occupants and how is the entire health of this building. So, and this is a summary of the different use cases that we mentioned earlier. First of all, we need to build smart and connected city. It's the same as building and campus. We have data input from the building systems. We can have like BMS systems, we can have lighting and security. All this data will input inside, we will need to input this data into a digital twin platform and combine with external data such as weather and such as first response. And of course, we also have our blueprint that is our BIM model for the building, for the campus, as well as for the cities. Then we can apply machine learning as well as AI model to have reasoning for these different data so that we can measure ourselves against our KPIs. So what is our KPI in terms of efficiency? What is our KPI in terms of safety and health and emission, environmental impact? Then we can have contextual specific solutions in terms of these different aspects. For example, we can analyze the occupant behavior to provide a better service for the occupants. And we can also have a better insight in terms of the systems and device behavior. So we can do predictive maintenance instead of a more responsive way of maintenance. So many of you may think, oh, that is a very complicated way to build a urban digital twin, whether it's for building or for campus. So of course, the overall, if we want to boil the oceans, it can cost anyone millions of dollars, but we can always break down the bigger problem into smaller problems. So for example, we can first create just a static model so that when different users, they are seeing this static model, they will create their own use case. So for example, the emergency response team, they may want to use this building platform in terms of fire simulation or emergency evacuation simulation. Then we know what is the use case. We also know what are the data that are required. Then we will know, okay, we probably need a fire, a smoke sensor to be deployed in the building. And following different use cases, then we know that what kind of IoT and edge networks and infrastructure to be built according to different use cases. And after that, different domain specialists will come in, and some of them, they may want to build predictive models, and if they are from transportation departments, they may want to have or high definition roads, and they may want to simulate in terms of connected and autonomous vehicles, and so on and so forth. And last but not least, I would like to introduce about our Dell participation in terms of digital twin development. And Dell is the founding member for Digital Twin Consortium, which is a collaborative organization driving the innovation of digital twin technologies through consistent approaches and open source development. And the next consortium that Dell is the technical member is Open Geospatial Consortium. And this consortium specifically focuses on urban digital twin. So we are always up to date in terms of the latest regulation and the latest development internationally regarding urban digital twin. So let me summarize on why it is important to have urban digital twin. We know that urbanization the progress for urbanization is very fast, and more people are moving into the cities. So this creates more and more problems for cities to handle as well. So for example, 90% of the major construction projects run over budget, and more than 70% of global carbon emissions are created by cities. 50 to 70% of all carbon emissions in cities are created by buildings, and less than only 1% of commercial buildings in US are green. So it really creates urgent need for us to gather all this data together to build urban digital twin, even from a smaller perspective and smaller scale, so that we can kickstart gathering all the data and to help city to build a better future. Thank you for your time for the past 15 minutes. And now I would like to pass the time back to Christine for the Q&A session.
Thank you, Pailu. Moving on to our last segment for the day, let us welcome all the speakers to join in the panel discussion segment. And this segment will be moderated by Anthony. Handing the time back to you, Anthony.
Thank you, Christine. Thank you very much, Martin and Pailu, for giving us such a great sharing on digital twin. Martin has introduced as quickly, as simply as he can for helping us understand digital twin. And Pailu, I think you did a wonderful job sharing us the application and making it quite simple to digest how digital twin can be applied in urban solutions. Now, to kickstart, I think we have some questions already raised by the audience, and I think Martin has answered some. So, but for me, maybe into a more generic questions, maybe I'd like to ask Martin, is building a digital twin expensive?
What a great question. Someone always has to ask that, don't they? And by the way, I've been answering some of the questions live as fast as my fingers will type. So happy to do those offline if we don't get through them all today. Is it expensive? Yes and no. It's like everything else. Is building a house expensive? Is building a building expensive? It depends what you're really trying to achieve. So I would say, like, we've started doing very basic digital twin projects that yeah, okay, I mean, obviously these are commercial numbers, so not so easy, but let's say some just initial photorealistic digital twinning modeling around sort of $20,000 to $30,000, depending on which contractor, which country. I mean, the country matters a lot, right? You know, the labor rates are drastically different. So, you know, you can start relatively low cost, but, you know, the full digital twin, I mean, take example of Singapore, right? We are one of the few countries that truly have a digital twin, Singapore, and you can Google all that information. Now, clearly millions and millions of dollars were spent on that, because that's bringing all the data points in across Singapore for agencies to use. You know, so that's a real kind of, and I love Singapore for that, because it's kind of a gold reference model for the rest of the world of how things are done. But, you know, is it finished? No, a twin model never really finishes. You grow and you optimize it, you put new machine learning algorithms, you feed it with new data, and you get continuous, feedback, continuous return on investment from that twin. So hopefully that answers. So depending, you can start from a few $1,000 all the way up to many millions of dollars for an entire country. And it's never stops. You'll always, just like everything in life, whether you're doing cloud or database, there's always a continuous evolution of that journey as well.
Thank you, Martin. So guys, there you have it, from few thousands to few millions, depending on what you're looking for.
I'll give you a good price if you want to spend a few million.
Okay, we'll take this offline. I was going to ask Bailu about which cities have developed city-scale digital twin, but Martin have answered Singapore. So for Bailu, maybe you can share with me which use case of urban digital twin is more matured and having the most demand.
Okay, so from our experience, most of the urban digital twin use cases are still in developing stage. And again, from a city life cycle management perspective, we see more and more demands for simulation use cases. For example, the simulation on mobility that we shared earlier. And for operation and maintenance, we are seeing more demand for digital twin for campus and buildings, so that we can build an infrastructure at a smaller scale. So later on, we can also connect the digital twin for campus and buildings back to the city level infrastructure.
Thank
so
you.
Yeah, more on simulation use cases as well as the smaller scale campus and building use cases.
Yeah, and just to chip in there, I mean, if you think about it, it does make a lot of sense, right? Because, putting up, making huge multi-million-dollar investments in buildings is risky business. There's a lot of finance. So if you can share your data model, if you can already show your investors, potential people that are purchasing whatever it is you're developing, this is how it's going to look. This is not just how it looks like the classic kind of AutoCAD pictures. I mean, a building that comes to life, a building that you can walk through, a building that you can experience, one where from your real sensors or virtual sensors, what's going to happen if you make adjustments, if you do want to do renovations, all these things. And that's the beauty of digital twin. It's beyond the classic drawings that we all see, the 3D drawings. It's far beyond that. And we do see the simulation one. I have to keep stressing is really at least for the ones we've got, is can we simulate before we spend money. So just emphasizing what Bailu said.
Okay. Thank you, Martin and Bailu. So I'm going to just pick a question from the audience, although I think Martin has answered a few. A question from Stefan Lien. How big is the data storage file size of digital twin? In other words, how much transmission bandwidth is required to transfer the data to the cloud? So either one of you can pick up this.
Yeah, it's like I can do.
Really to go.
yeah, I always okay. Let me start, and then Bailu can sort of chip in. Right. Okay. So the Singapore National Stadium. So the first thing is, well, what is the data size? I mean, what are we looking at there? I mean, we've obviously got our 3D model, we've got our sensors, we've got our lighting information. So we've got the kind of the base model in. If we now start to add photographics and proper real life photographic imagery to that. Visual walkthroughs, rendering, and things like that, then certainly that size will grow. Now, do you need to send all that information over the wire? At that time, you can argue. I mean, basically, you're just, unless it's real-time data, like I need to know what's coming from a video camera, I need to know what's coming from a light or a conditioner or the roof, opening, closing, something like that. That's the real-time data. That's the bit that you're going to be most interested in. And that typically doesn't have to be a lot, because IoT devices in general are not really bandwidth hungry. They're not Netflix videos or YouTube videos in size. So those critical data points from your IoT is like your top priority information to run it well and to say, this is the digital stadium right now, how it should behave. And something's different now in what's actually happening that I'm reading real. And so it doesn't have to be large amounts. Now, over time, you will, of course, create an archive, a digital threading of that, and so you will be building a lot more information. So yeah, so it can start very lightweight, and then you'll just stream your basic models over time. So hopefully that answers, and it's a really exciting. So prioritize what you need first to operate your building or your facility most of your city, like your traffic lights, you know, like those have to be always priority over perhaps something that's interesting from a video camera, but can be done streamed over a period of time in a batch, a more efficient compression batch way.
Yeah.
Really good question though. Thank you.
It is a very good question. So I think there's a question, maybe it's meant for me, from Paisan. Does SG Tech own the digital twin platform for Singapore? Can it be used by external parties and companies? The answer is no. SG Tech do not own the digital twin platform for Singapore. I would think the government would own it, but it's a nationwide implementation for city planning and township planning. As you can see, there are many projects ongoing in Singapore on and applying digital twin. So if you have a solution that you may be able to offer, you can consider joining Smart Nation chapter and then connect to Martin, who is our EXCO member, and then you will be a little bit into the ecosystem.
Love to see you join. More the merrier.
All right. So I do have another question. Maybe for Martin. How long does it take to build a digital twin?
I knew you would ask that somehow. That's a bit like the how much money, isn't it? If you want me to build a digital twin for my mug on my table, I can do it very quick, right? If you want me to build, like the example that was a good example earlier, the National Stadium, and that, by the way, that is real. That is a real digital twin, right? Then clearly you're going to work with the different stakeholders. And I always say that if you can't get the data and you don't get the support, then you're never going to build a digital twin. You can build a vision, but you'll never get that into real life. So, typically like, now mileage will vary depending on who you speak to, but if you import all the drawings of, let's say you're doing a building and they're all up to date, and you're using the right vendor for you, I won't say which vendor, let's just say you're using the right, remember all those badges that I showed earlier? There's lots of people that are out there to help you. So people will give you different times, how to achieve something. But we have seen like buildings done in with the imaging as well, something like between 5 and 10 days to build the image model with all the imported diagrams from the AutoCAD world, the engineering world, the proper BIM information. So the model itself can be constructed relatively quick, but bringing that model to life with all the right data, there's your challenge right there, and that could take several months. So the bigger the bigger the project, the more data, the more stakeholders, the longer it takes. Yeah, hopefully that answers.
Okay, thank you very much, Martin. Is there any other questions from the audience? Let me have a look. No, I think we have time for one more question. So maybe I'll just ask.
Maybe you can put the feedback up, perhaps with if you want to contact us, we can put all the email us, contacts, join SG Tech. Maybe we have that slide.
Okay, I think I've been told we are running out of time. Over to you, Christine.
Hey, Christine.
Christine, you're in mute.
Always the classic in it, the mute. One day we'll hear about that.
Sorry. Thank you, Anthony, Martin, Bailu, for your insightful sharing. And thank you everyone for taking time to join us today. We welcome you to join us as SG Tech members if you are not yet a member. And please feel free to reach out to Martin and Bailu for more information. And lastly, we'll appreciate your feedback to help us to improve future webinars. And I'll be leaving the screen on for everyone to scan the QR code to complete the survey for the next 5 minutes. Thank you once again and hope to see you in future events.
So, thank you so much. Been a pleasure meeting you all in virtual world. Hopefully see you again in real life very, very soon.
Thank you very much, guys.
Thank you,
Bye-bye.
Anthony. Thank you, Bye. Thank you, Ken.
Thank you. Bye.